These 4 tricks are what separate a normal Mario playthrough from one of the fastest speedruns ever created. Every top speedrunner relies on them, and without them, a world record any percent run simply isn't possible. In my last video, we trained a local reinforcement learning model to beat the human world record in World 1-1, and at the end, I promise we go after the full game next. But there was one problem. Before we could even begin training in any percent speedrun, the AI first had to master every major glitch along the route. So I split the challenge into 4 separate experiments, each one more difficult than the last. Alright, let's have some fun. Let's start with the easiest one. Now, a flagpole glitch isn't easy by any means. Even experienced speedrunners spend hours learning it, but compared to the other glitches, it should be the easiest one for our AI. Normally, Mario slides all the way down the flagpole. The flagpole glitch simply skips almost all of that animation, making the level end sooner. The nice thing about reinforcement learning is that we don't have to train the entire level every single attempt. We can simply start Mario close to the flagpole and let the model practice this one section over and over again. But before it can learn the glitch, it first needs to know that the glitch is even possible. To teach it that, I first needed a successful demonstration. There was just one problem. I'm not a Mario speedrunner. So I spent way longer than I'd like to admit, grinding World 1-1 until I finally managed to pull one off. Now the AI had proof that the glitch was possible. Time to see if reinforcement learning could figure out how to reproduce it. At first, it looked like nothing was happening. Thousands of attempts went by without a single successful glitch. But after about 50,000 training episodes, it finally got its first flagpole glitch. And once it figured it out, things improved quickly. A few thousand episodes later, the glitch had gone from a lucky accident to something it could perform consistently. 1 glitch down, 3 more to go. Next up, the 1-2 wall glitch. And unlike the flagpole glitch, this one requires Mario to do something that should be completely impossible: walk straight through a wall. Normally, after reaching the end of the level, Mario jumps onto the ceiling and walks all the way to the warp zone. It works, but it's not the fastest way. Instead, speedrunners do something that shouldn't be possible. They simply walk through the wall. This works because Mario's position is tracked more precisely than what we can actually see on screen. With the correct speed and subpixel position, a tiny jump lets Mario become partially embedded in the wall. Normally, the game would push him back out, but by steering away from the wall at exactly the right moment, the collision correction behaves backwards and pulls him farther inside instead. Once Mario is deep enough in the wall, he can simply walk through it and reach the warp zone faster. Just like before, I created a demonstration and built a dedicated training environment around the trick. This time, however, things were noticeably harder. Most attempts looked exactly like this. The model either slammed straight into the wall or completely missed the setup. Every now and then it got incredibly close, which at least meant it was exploring the right area. Then, after 120,000 training episodes, it finally broke through. This almost took as long as the whole 1-1 training. And just like the flagpole glitch, once it understood the trick, it quickly became consistent. 2 glitches down, now things started getting really weird, because the next trick doesn't just break the level, it breaks where the game thinks Mario is supposed to go. Now it is time for the strangest one yet, the 4-2 wrong warp. Normally, Mario reveals a hidden vine, climbs all the way to the top, and only then reaches the warp zone. The problem is, climbing this vine takes time, and in speedrunning, every frame matters. So instead, speedrunners somehow enter the warp zone through the pipe. The crazy part is that nothing about the pipe itself changes. The trick is actually to confuse the game about where the camera is. Normally, the camera follows Mario as he runs through the level. But every time Mario bumps into a block, the camera falls just a tiny bit behind. Just a few frames, but enough to matter. For the wrong warp to work, 2 things have to happen at exactly the same time. First, Mario has to activate the hidden vine block. And second, the camera has to be lagging just enough behind because of those earlier collisions. If both conditions line up perfectly, the game loads the warp zone, as if Mario had climbed the vine, even though he never left the ground. Teaching this to the AI was much harder. It no longer had to learn a single precise movement. It had to coordinate two completely different mechanics and make them happen on the very same attempt. At first, it learned them separately. Sometimes it would hit the vine block perfectly. Other times, it would create just the right amount of camera lag. But getting both to happen together proved to be a completely different challenge. Hundreds of in-game days later, everything finally lined up. 3 glitches down, only one remained, and it would turn out to be the hardest challenge of them all. This one almost broke me. Unlike the regular flagpole glitch, Mario doesn't just have to hit the flagpole perfectly, he also has to be hit by a bullet bill at almost exactly the same moment. 2 moving objects, one tiny timing window. Miss it by a fraction of a second, and the whole thing falls apart. But before the AI could learn it, I first had to perform it myself. And unlike the other glitches, this turned out to be much harder than I expected. Ironically, I started getting regular flagpole glitches surprisingly often, which was impressive but completely useless. The AI didn't need another normal flagpole glitch, it needed the real thing. Every failed attempt meant no demonstration, and without a demonstration, there was nothing to train. Then, after what felt like forever, everything finally lined up. Finally, the AI had something to learn from. Now all it had to do was reproduce one of the hardest tricks in the entire speedrun. Just like before, the AI started with absolutely no idea what it was trying to do. Most attempts almost always ended in a normal finish. Interestingly, it rediscovered the regular flagpole glitch surprisingly quickly, which was encouraging, but also a reminder of how much harder this challenge really was. This time, a normal flagpole glitch wasn't enough. Every now and then, it came unbelievably close. Close enough to know it was learning, but still not close enough to count. Then, after over 1 million training episodes, it finally did it. 4 glitches, 4 dedicated training environments, 4 problems that, at the start of this video, our AI knew absolutely nothing about. And now, it could perform every major trick needed for a Super Mario Bros. Any % speedrun. So, the AI finally had every piece of the puzzle. But learning each glitch on its own is very different from performing all 4 in a single uninterrupted run. And that's exactly what we'll be trying next.